All right. Welcome again to TestWizardry. As I said, today's class, we're going to step things up a notch. We're going to learn how to build a project with Maven. We're going to learn how to use GitHub to check out our project, and we're going to learn how to use TestNG to test our code. And we're going to take the project that we've gotten so far and Mavenize that project, or rather create a new project from scratch with Maven to see how that works. So let's go ahead and start off with Eclipse and creating a new project, right? Let me close down all this other stuff. I'm going to launch Eclipse. Give it just a minute here. It's starting up my Windows version of Eclipse so I can follow the example. So to create a new project in Eclipse, we would normally, in the past, we've gone File, New Java Project. But what we want to do is we want to create a Maven project. Now, Maven is a build automation and software project management tool, primarily used for Java. You can see there's a lot of different options here. It has general, like a general Java project or file, Git, Gradle, Java, Maven. So what we want to do is we want to go to Maven project, and then there's also these options for oomph. I'm not even sure what that is. They build the Eclipse installer, TestNG, XML, or other examples. So what we want to do is we want to select a new Maven project. Now, a Maven project is a Java project by default, and most Java projects are Maven projects nowadays. You don't need to use Maven, but the bulk of the Java community does use Maven. Some other tools that you may have heard of in the past are Ant, and another one that's gaining popularity that we saw is Gradle. Ant is an XML-based build tool. Maven is a build tool with more things, including dependency management and project structure. Ant is more flexible than Maven, but Maven takes away a lot of those choices in the interest of we don't usually care so much about how we organize our files. We just want our files and our project structure to be organized, and more importantly, to be consistent. What Maven gives is the consistency across projects, that it sets up source folders in the same standard way. All right, so let's look at this new Maven project, right? So we want to go ahead and create a simple project, meaning not to use a Maven archetype. Maven archetypes are essentially outlines for different projects. So you might have a Spring MVC web archetype. You might have a Struts or a Wicket or other framework project type. And you can select those archetypes, and it will create the boilerplate and the folder structure for you. So there's all these Maven archetypes, but we're not going to make any particular Maven archetype. So we can click Create a Simple Project. You can choose your default workspace location, or you can create a new workspace, whatever. A workspace is just a group of projects, and that's an Eclipse concept. Working set, we're not going to add that, whatever. So when we create a Maven project, Maven, the first thing it does is give your project an ID, a unique ID. Now, your group ID is typically your organization. So you might see something like Com, Apache, Maven, for example, as one. It often follows the domain, but then you have others like JUnit, where the group is just JUnit, or with TestNG, I think it might be com.beust, B-E-U-S-T, TestNG. I'm not sure, but that's because that's the name of the author of TestNG, the original author. But what we're going to do is we're just going to call our group TestWizardry, right? We could call it com.testwizardry, but that's just something extra we need to type. Now, the artifact ID, this is our project. So if we have a unique group, and in order to be with Maven Central, you need to register your group. So it might be, TestWizardry or com.testwizardry or your organization, whatever, artifact is your project. So your organization has this namespace, this group ID, and underneath that it has whatever additional project. So the artifact ID, the artifact we're going to create, is this going to be the TestWizardry. We'll call it the TestWizardry console because it's the TestWizardry console game. You can see I've got another one called TestWizardry intro up above here. Now version, that's whatever you want to call it. By default, it includes a snapshot, meaning it's not a release version. So it has 001 snapshot, and what you might see for a project, it might be version 1.2.3. Now what this says is it says the version is, this is the major version, version 1. The second one is the minor version. Now, major versions may be incompatible between different. Minor versions should be compatible. So 1.0 should be compatible across all 1.0 features. 1.1 may have changes or additional features. 1.1.1 or 2 or 3 or 4 or whatever should all be functionally identical for the minor version, right? So the major version should be feature equivalent or API compatible. The minor version should be functionally equivalent, and the sub version here is usually a build number, and so you might have a bug fix. You know, version 1.2.1 has a bug. Version 1.2.2 is a new build that fixes that bug. And that's called semantic versioning. The idea being that looking at the version number, you can tell how compatible it is with another version of this same artifact. So what we'll do is we'll create, we'll go ahead and stick with the default, which is we'll go 0.1.0 snapshot. And snapshot means, hey, this isn't an official build. This is just a snapshot. And we would remove the snapshot once we feel it's ready for release. Now, packaging, you can release. Maven not only allows you to build a project, but it allows you to package it and deploy it. So it could create a POM, which is a project object model. We'll talk about that. A jar, that's the standard. That's a Java archive, or a WAR, which is a web archive, which is a jar with a manifest XML that tells you how to deploy it on a web server such as Tomcat or Jetty. So we want a package of jar, and then you can specify a name. This is optional, but it's TestWizardry console game, right? We'll call this a fun game based on Harry Potter. You can add a description name. They're totally optional. Now, Maven can also have a hierarchy of projects. So you might have a parent project. We're not going to worry about that right now. So we've got the artifact TestWizardry console. Let's go ahead and finish this. And you can see it created a project. Now, I've got my old project here, and it has the JRE system library. That's a link to the Java. And it has source, TestWizardry, and it has my files here, right? My TestWizardry console, which is the main entry point, and welcome to TestWizardry, what is your name, etc. So that exists in this other project. And notice it just goes source to TestWizardry. But when we go to our TestWizardry console, we have, well, it doesn't have any files in it yet, but it has source main Java, source main resources. You can see here resources over here. We have our acceptance letter. And I haven't shown you this yet other than in demonstration, but I just cut and pasted that from the internet, which this is the official Hogwarts acceptance letter text, I guess. But our resources go under source main resources or source main Java. And alternately, we have source test Java and source test resources as well. This is a way that you can write tests that are included in your project, but are not part of the main source code. And you can see the Eclipse project here follows this similar format, except it doesn't have the Java. It has source, it has resources, and it has test resources, etc. And you haven't seen all this on this project. So if you're seeing files like test scripts that don't look familiar to you, that's okay. That's just for illustration. But what we want to do is we want to create a project, and I'm actually going to just cut and paste a bunch of stuff in here by creating my files, and we'll talk about the project structure. Now, the other thing you'll notice in this Maven project is it has a little M here to indicate it's a Maven project, and it has this pom.xml with the M icon on the file. Now, a pom.xml is the project object model. It contains information about your project, and you can see here we have this information: the group ID, the artifact ID, the version, the name, and the description that that we just entered in that dialog. This is the meta description information about your project, but there's also other things. The POM will grow as we build this project, and it tells us things about how we're going to build the project and what are the dependencies we use. And those are some of the main things that Maven provides, right? It's an automated build tool. So it has these targets, right? It has a build target, it has a test target, it has a deploy target, or an install target, or a release target where you can publish your repositories publicly. And that's probably the biggest benefit of Maven, because everything follows this same project structure. Not everything, but since the de facto standard for publishing projects in Java is Maven, it allows you for open source primarily, but also some closed source projects. But you have this Maven central repository, and you can go to mavenrepository.com, or I think it's mvnrepository.com. Yeah, mvnrepository.com. It has a list of all the different Maven projects that are available. And you can search for them on the website. You can see my internet connection is slow because I'm screencasting, and it's not going to get there right away. But you can see from the Maven repository, it has everything. So you can look for everything. For instance, you can look for Selenium, and it shows this official Selenium Java release. And you can click on that, and you can see the latest version. You can actually click on, so we've got the 4.0 alpha, and you can download the jar file. So the actual Selenium library, you can download that and install it directly in your project. But even better, you can just include it as a dependency in your Maven pom.xml. And then, so there'll be a section called dependencies. And I can actually just take that and I can include Selenium right here just by cutting and pasting this little snippet of code from Maven repository or Maven Central. And I can include that in my project, and I'll just improve the formatting a little bit. Just add some indentation correctly. That works. And you can see the group is org selenium hq dot selenium. The artifact is selenium-java. The version here is 4.00-alpha-6, which is kind of weird. Now what it's doing, it's building my project, even though I have nothing in it. And what it's doing when it's building is it's downloading Selenium as a dependency of the project and all the dependencies of Selenium needed in order to run, which saves a ton of time when you're creating projects. So you'll have this list of dependencies. This is probably the most common thing you'll do with Maven, is you'll add your dependencies and they'll just automatically be resolved for your project once you know what they are. All right, we'll let that, well, we don't want it to take up all our screen, so we'll let that run in the background here while we go ahead and create our project. So under source main Java, what we want to do, I'm getting a click warning me of something. Oh, it's not going to let me use Eclipse while it's downloading that. You can see it's downloading all these different things. So I'll cheat and I'll hop over here to show the TestWizardry Java core, which is, right, this contains all the stuff we have created so far, including in our TestWizardry package, right? We have wizard. Wizard extends person, implements magic user, which also does the same thing, and our witch and wizard classes look identical, except we have this default that it calls person. That's what super means. Super constructor. And it passes in the name that it gets from the argument and the age that it gets from an argument. And a witch specifies a female and a wizard specifies a male. That's kind of where we left off on Friday last week. So person has a name, has a gender, and has an age. So that means that every wizard also has a name, a gender, and an age, and likewise with a witch. And wizards can cast spells. A spell right now just has a name, like Wingardium Leviosa or Accio, whatever. And that's all it has for right now. It's starting out as a definition. Potion, well, a potion contains, I suppose a potion should have a name too, but right now it just has instructions, you know, and ingredients. Mix 1 eye of newt with 1 wing of bat, stir carefully under medium heat until softball stage, and then I don't know. It's much like a recipe. And I talked about how a potion might inherit from or implement a recipe interface. And then there's something else I didn't mention, which is a muggle. A muggle is also a person, just like a wizard. Muggle extends person, just like a wizard extends person. But muggle does one thing different. It does not implement magic user. So it doesn't have these functions or methods called cast spell and brew potion. Magic user, if we look at, is an interface. It doesn't do anything. It just tells us what a class that is a magic user can do. So it's kind of a contract. It says, if you give me a magic user, I can cast a spell. If you give me a wizard, I can cast a spell. But if you give me a muggle, I can't cast a spell. So that's the interface, which is a contract or a description of what an object can do. And we'll see later how that works. For instance, if you have a collection, we've already looked at another type here when we looked at a potion, right? A potion has a list of ingredients. A list is also an interface, and it extends collection, which is also an interface. And it has, so a collection has a size. If you have a collection, it will also tell you, is it empty? It will tell you if it contains an option. If your list of ingredients contains mandrake, well, then you can see that from the list. And it has an iterator. An iterator is another interface. An iterator will tell you if it has next, right? Are there more items in this list? It allows you to remove or do something for each remaining item in this iterator. So an iterator is a way to iterate over a collection like a list. And a list is like an array. That's why it has 2 array. It is a fixed number of things, a set of ingredients. Now, an array is fixed permanently in size unless you create a new array and resize it. A list, unlike an array, can grow in size. And unlike an array, it tells you things like, well, are there more? And you can iterate over those items. And we'll talk more about that later when we talk about collections in the future. In the meanwhile, let's hop back over to our other Eclipse instance and see what we've got. So we've got this project object model. I've got this error here. What are my warnings? Build path. So it says build path specifies execution environment Java SE 1.8. There are no JREs installed in this workspace. So Maven also has a way you can specify that sort of stuff. And I'm just going to gloss over this, right? We have build. I want that big. All right. What we have is we have the Maven compiler plugin. Maven has not only a project structure and these dependencies that you can install, and the archetypes, which can define project structures. It has plugins. So let's look at the Maven compiler plugin. What this does is it'll tell us what version of the compiler we want to use. And let me just expand this out so that we can see it better. And you can specify using a specific JDK. Oh, and yeah, so first I've got to specify that plugin, and then I can specify my build. So build plugins, plugin. I'm just going to, well, I actually don't need to go to all that. I'm just going to let this fill in for me, right? It's going to let me know what I want to plug in. Plugins. So it has multiple plugins, and under multiple plugins, it has one or more plugin in the XML. And I agree that XML isn't, it's not the preferred way to define things mainly nowadays, but Maven was built back when XML was popular. Gradle is a tool very similar to Maven that actually uses the Maven repositories and allows you to resolve dependencies using the Maven structure. But Gradle is written in Groovy, which is a simplified version of the Java programming language. So your Groovy build files will look much cleaner and easier to read than the Maven XMLs, and you don't have to remember all this XML and closing tags. So what we have here is we have the group ID, the artifact ID, and the version, right? So I'm just going to paste these in here. And then, so we've got the Maven compiler plugin. I'm telling Maven, use the Maven compiler plugin. And in my configuration, I want to specify that I want a source version, and you can specify version 14 or 15 or 8. We're going to stick to version 1.8. And here, this is my Windows. Besides source, I also want, so I'm compiling my source as version 8, and I'm compiling my target to version 8 or 1.8. And then there's one other thing. Maven will redirect output, and I'll just need to remember what the I'm going to ask the internet how I think it's redirect output to file false. It'll tell me. If I can spell it, that's why I want to cut and paste. Yeah, that's not quite the exact syntax here. Apologies for the slow internet. Looks like this one's probably the one I want to see. Stack Overflow, you failed me. Twice. All right, whatever this, the top site, send Maven output to console and log file. Looks like it's just going to take some time to download it. How long has it been since you've had to wait for a text-based site to load this long? Hopefully I'm not lagging too much on my audio as well. Looks like this has also failed me. All right, we're not going to worry about that right now. IntelliJ will give me hints on what the options are, and Eclipse doesn't want to be doing that for me now. suppose what I could do, I could cheat and go look at one of my old files. And it doesn't want to, yeah. All right, forget about that for now. Okay, sorry about that. So I'm telling Maven what version of the compiler to use. So it says compliance is one, but JRE 14 is used. So I can go here and I can go to project and I can rebuild it. I'll hit clean. Still gives me these warnings and I've got an error. Project configuration is not up to date. Select Maven update project. Project. That doesn't even say Maven update project. There we go. Oh, you know what? These warnings might be outside of the Maven. Here we go. We've got yeah, we still got this compiler complaint. All right. I don't think that's going to affect me anyway. Let's create some files. So in our thing, we want to create our package, our TestWizardry package. And we want to copy in our different classes. So I'm actually just going to drag and drop these through the magic of, I don't know, the internet. So I've got a witch and I've got a wizard. So this is complaining I don't have a person, I don't have a magic user. So I'm going to drag person in here. And I'm going to drag magic user in here. And you can see person should succeed. Oh, person needs a gender. We're going to drag gender in here. Okay, so now we've got gender, which is this enum, male and female. We've got person, which includes gender. That's what person was complaining about. Person now compiles without errors. There's no red X. Which extends person, implements magic user. Magic user looks like it's okay. Oh, we need spell and potion. So I'm going to grab spell and potion and drag these in here. And there we go. It didn't take the first time. Potion goes in there and spell goes in there. All right, so now we've got everything seeming to work. We've got witch, wizard, spell, potion. Let's see. We also have muggle, which it isn't complaining about yet, but it will in a minute. A muggle, remember, is a person who is not a magic user. So they can't cast spells. And that maps to what is correct in Harry Potter. Now, the other thing we need is we need our TestWizardry console, right? So let's create a new package. And we'll call this TestWizardry.console. You can have a hierarchy of packages. In this case, TestWizardry is the parent package, console is the child, and we will grab our TestWizardry console program and drag that in there. Let's try that one more time. Okay. This looks like it has some issues too. Okay, it says import Java util scanner cannot be resolved. That is very weird. Oh no, it's saying TestWizardry. Oh, wizard. We grabbed witch, but we didn't grab wizard. So let's grab wizard. All right. And now we can see that we've got our TestWizardry console app. It says, what is your name? And it says hello name. and then it asks so forth. Let's run this and see that we've got everything working. You can see it says it's creating this type hierarchy and it's compiling all our files. And here we launch our console. And what is your name? Well, let's try this. Harry Potter. Hello, Harry Potter. Are you male or female? Male. You're a wizard. How old are you? Well, I'm 11. And then it says Harry is an 11-year-old wizard. Now, this is the part that we're going to introduce our tests for. And I didn't show you how to do this yet. So this is something you might try to solve on your own. Oops, I wanted that problems view. Window. It'll probably come back when I create a problem. All right, so I have everything here, but let's see. What I don't have is, I don't have this program here, and I'm going to just drag this over from my other version of Eclipse. So I have here these options: Hermione, Harry, Aaron. That's me. I'll capitalize my name. Oh wait, there's a reason that's not capitalized. And I created these abilities that a person knows how to tell you what it is. I mentioned overriding toString briefly, and it looks like I've got some formatting issues. What I'm doing is I'm capitalizing the first name, and it says, so Aaron is a or an age. So we see here, where is our output? I'm just going to run this again. And I can say, Aaron, and are you male or female? I'm male. You're a wizard. How old are you? I'm 44. That's too old. Okay, I got to say 11. 11. Aaron is an 11-year-old wizard. And what that's doing, it's calling this, it's saying system out, print line, player. And it tells me all this information I know about my player. And you can see another thing I've done is refactor create player, right? So create player takes a name, a gender, and an age. It creates this method, which does this all at once. So we decide if we're a witch or a wizard. And then we create a new witch or wizard accordingly, passing in the name or the age. Now, new witch and wizard extend person, and person has this toString method. Now, any object has a default toString. If you remember from last week, it would say witch at 1, 2, 3, 4, 5, 6, or whatever, wizard at 1, 2, 3, 4, 5, or it'd be TestWizardry.wizard, right? So for instance, I could create a new class, right? Called Dementor. If you got a Dementor, and it's not going to do anything, right? And then what I'll also do is I'll create a class here, and it will be in the package lesson. We'll call this lesson 6. And my class is going to be example. I'll call it lesson 6 Scratchpad. All right, and then we've got a public static void main string array args. And then I just want to see what a Dementor says. So I'm creating a new Dementor in print line. And then what it's going to do is it's going to call Dementor toString. And it doesn't have a toString, but Dementor extends object, and object does have a toString. So first thing I do is I'm going to import Dementor. That takes care of that issue. And then I'm going to go ahead and run my main file. All right, see TestWizardry.Dementor. That's my package and my class. And then @ symbol, and then some unique string, right? If I create another Dementor, it'll be a different number, but everything else will be the same. So these are unique dementors, and I can prove that by saying if, well, I can't prove that because these guys are ephemeral. They only exist within the scope of that function. But I could say dementor A equals new dementor and dementor B equals new dementor A and B. And then if A equal to B, that's an extra equal sign. And then else, print different. And you can see they're different. Now we do the same thing with person, right? We'll do person A equals new person. And person B equals new person. We need to import person. And I click on that. I could just as easily type import TestWizardry person. Where's my typo? Oh, a person needs arguments. So we need a name. Now I can call it Harry Potter. Gender male and age 11. Hermione Granger. Gender female and age 11. Does it like that? It doesn't like that. Oh, I need to import gender. Now, an interesting thing we can do is we can do import. Oh, wait, we can't do that with an enum. I tried that already. So we've got two people. Are they the same? Well, let's find out. No, they're different. And rather than printing out the person to string, right? We can also just, we can remove this to string. And we run this again, and it will say TestWizardry person 1 and TestWizardry person 2. Now here's something interesting to see. What if we create two people that are exactly the same? So they're both males, they're both named Harry Potter. Are they identical? No, because their identity is different. And what we can do with this is we can use the dot equals method. They're still different using dot equals. Now, just like toString, every object has an equals method that we can override. So let's go ahead and override equals on person. Equals. And that's not Boolean, it's not void, it's Boolean, right? And what we want to do, this is optional, but important to do. We want to specify that we override. So we're overriding equals, and then we want to pass another object. We'll call it O. Must return a type Boolean. Okay, so return. So to start off, we just return true. All people are the same, and we should judge them accordingly. They're the same because our person.equals always says they are. But we don't want to do that because all people are not the same. Let's return false. So they're different. Let's be a little more specific. What we want to do is we want to say if this dot name equals, let's call this other. Other dot name. And now here's something I don't think I went over very well. but I might have mentioned it briefly. And so logical and will do multiple comparisons within a loop. So let's do if this name equals other name and this double ampersand is and. So if this name equals other dot name, well, I guess what we want to do first is we want to say if type of other well, that's what we want to do is we want to cast it, I guess. Let's just compare it to other people for simplicity's sake here. Oh, I'm not returning anything. That's the problem. So if the name is the same and the age, with the age, it's an integer, so we would actually do a equals operator, other dot age, and this dot gender equals other dot equals. So in order to organize that easier and show that our age is the difference, same here. So we have these three comparison, name, gender, and age. We need to move our ands because I cut and pasted differently. So we've got three comparisons. Then return true. So if they're the same name, the same age, and the same gender, well, they're the same person. Otherwise, return false. What is our error here? Oh, what must override? Now I'm confused. Remove. Oh, overrides. I think that's what we want. No, over. All right, I'm going to look up something. Maybe I'm following the wrong interface. In the meantime, while that's loading, I can go ahead and, oops, let's move this one out of the way so we can look at this one. So we've got our equals, which runs the comparison. We go to our lesson 6 scratch pad. Now it should say they're the same, right? Same person, Harry Potter. Now I suppose there aren't that many 11-year-old Harry Potters in the world, although there may be more than one, especially because this is a player. We don't need to mentor, but there might be a lot of John Smiths that are the same age. So this probably isn't a perfect comparison, but it's for the model of the game, it lets us know. Maybe we would have something that, and what's that? But we can see here, their identity is different. So even though they equal the same thing, they do not equal the same thing. They're different, different identity, but they're the same object, at least as far as our equals comparison, we're overriding the equals comparison is. Now, another thing we could do is we could say person A2 equals person A. Now it's going to get a little bit more interesting. If A equals A2, and we'll go ahead and do this too. Now you can see they're the same person. Oh, well, A2 and B, we'll print them all. So we can see the ID of these first two because we're copying a reference to A in A2. So these are actually the same object in memory, A and A2. Whereas B, even though it's created to be identical, it's like the identical twin of the first character or the first person. So they both come across as same. So that's one thing I wanted to point out. Now, I said there's another thing I wanted to do, and that is introduce you to Git. I don't know if we're going to get to test ng, but I want to introduce Git because that will allow you to keep up with everything I'm doing and see the changes and also review stuff and make changes yourself. GitHub is a hosted Git repository or many repositories. It allows anyone to create an account. And we might actually do that here. So I guess I want a new incognito window, right? So you would go to github.com if you don't have an account. And you can sign up for a new account. All you need to do is create your own username. Mine's Aaron, Fiji Aaron. I also have one for my company called OneShore, and I also have one specifically for TestWizardry. So I can't create that, but go ahead and create one. Enter your email address and your password, and it will, sign you up for a free GitHub account where you can create your own repositories, or you can copy existing public repositories. So when you have an existing account, you can create a new repository, and you can call it whatever you want. So mine here is Fiji Aaron. I have all these other ones I work with. I might call it TestWizardry dash example. I'm not sure if dot's allowed. You can choose to make it public or private, depending on your account type with GitHub. You can have private repositories that no one else can see except for people you share with, or you can create a public repository and you can optionally add some files and specify a license, if you want to share open source. It shows you how you can create code here. You can cut and paste this code into your command line and run it. You would also need to have Git installed on your machine. I don't know if Windows has Git installed by default, but Mac and Linux usually does. And so Git is a command line tool that you can check out repositories or check in your code and push. So what I want to show is how you can use Eclipse to check out, well, not this TestWizardry example, but specifically the TestWizardry Java core, which is the one we're going to be working with, right? So if you go to github.com/testwizard or /testwizardry/testwizardry Java core, I'll paste this into the Slack chat. And I'm actually going to have to unplug. So apologize if the sound is a little worse. But there's a few ways you can check this out. From the command line, you can click on code, and there's different options, HTTPS or SSH. Let's just stick with HTTPS. That's the most common way most people work with it. Now for a public repository, you would type Git Clone, and then the URL here, github.com/testwizardry, TestWizardry Java core. And that's right, I wanted to paste this into the chat here. And there's the direct link to the repository. When you're logged into GitHub, or even if you're not logged in, you should be able to get this URL. And you paste this, and before doing that, I'm going to go to my temp directory. Git clone, now the URL. Oh, it already exists. I'm going to make a directory. Oh, I've got too much going on here. Okay, good. All right. Well, that's okay, as long as I got rid of this. Okay, so I have an empty directory. I'll go back and git clone
into TestWizardry Java Core. And you can see it creates a folder called TestWizardry Java Core. And I have all the files. I have my pom.xml. I have my source folder. And you can see here under, so I did tree, which is a command you can install, which gives you a little bit of a format to show you. I've got Scratchpad, TestWizardry, gender, magic user, muggle, all these files in this folder hierarchy structure. And I can also do open dot, and it'll show me in the file explorer. Open. There we go. I've got my source, main, Java, and all this stuff. So that's how you can get it from the command line. And then I could, just in Eclipse, I could file, I could open a project from the file system, and I can go to temp slash TestWizardry Java Core. And I could get that. But I'm not going to do that. I'm going to show you the proper way so that Eclipse recognizes Git and everything. I'm going to show you how you can check it out in Git. And in order to do that, let me bring up my other Eclipse. I've got running the Windows version of Eclipse. Bring that on screen. And so I've got this TestWizardry console, which I just created, and I copied the files manually. But instead, what I'm going to do is I'm going to check it out from the repository. So I'm going to do File, New, Other, and I can check it out from Git, a Git repository. And it says repository directory. It can be on my local file system. It can also be from here. So I can grab the URL. And this might claim a clash of directories like I had on the command line. Oh, it says don't enter a URL, but a local absolute path. So it actually wants to find it in the temp, whatever. Right, so I can go to, oh, but this is the Windows, and working with parallels is somewhat confusing. Let me see. I can import from Git. Import project from Git with smart import because it'll recognize it is a Maven project. Now, rather than existing local repository, I can clone a URL, and I'll type that URL in. Why doesn't that work? All right, here I'm running up against my familiarity with Eclipse. Oh, it has to go through this wizard. Okay, now we've got the URL, the host on github.com, connection protocol HTTPS, authentication user and password. You shouldn't need that, but I will need it to commit. So I can do Fiji Aaron is my username, and I can type my secret password. I can store it. And now what it will do is just like from the command line where it downloaded the files into my file system, it will download it into my file system, and Eclipse will be aware that it is a Git repository, and I can do things like I can commit and push and pull from Git. By push and pull, I mean to upload and download. And one thing that Git does is it does a diff of the files needed. It says this file has changed, this file has not. I do not need to upload or download or change this file, which makes it much more efficient, which is really valuable on larger projects. All right, so when fetching a commit also fetches tags. Yes, we want to do that. And the initial branch is main. And it's going to put it in a directory called Git. That's okay for now. For demonstration purposes, you might want to have it. For instance, I have a folder called TestWizardry that I'm using as my workspace. A master password. Do you want to provide a password hint? Not at this time. Finish. All right. So now I have this TestWizardry console, which I just created via cut and paste and drag and drop, which was kind of annoying, I'll admit. But then I have this TestWizardry Java core, which has my default package, my TestWizardry, and my TestWizardry console. We can run this project as opposed to here. I have the same files, TestWizardry console. And we have this other thing. I have, I don't have it over here. It was on my other Eclipse version, the lesson 6 Scratchpad. So today, looks like what I did is I was able to introduce Maven, create a Maven project just by dragging and drop all these things, and then show you quickly how to check out from GitHub. Let me show you one last thing, which is how to check into GitHub. And what I'm going to do is I'm going to do a little drag and drop here. I'm going to take, rather than default project, I'm going to go into my TestWizardry Java core, and I'm going to drag this quick comparison file that I did. And what I'm going to do is rename this one to lesson 5 Scratchpad. Scratchpad is just this crazy word I use to specify. So, and you can see this one is added to it. What I want to do now is I want to add this lesson 6 Scratchpad, this file that compares the genders or compares the persons. So I would go to team, and what I want to do is I want to add to index this file, and you can see it has this little plus here, right? And then what I can do here is I can do team commit. Now what it does is it brings up this little dialog at the bottom. It's Git staging. It's saying I have this one file, and it shows there's other unstaged changes. We don't want this probe, but we do want the lesson 5 Scratchpad. But we're just committing these files right here. Well, we actually don't care about Scratchpad. We'll clean this up a little bit later. But add lesson 6 examples just as a commit message, so I know when I look at it. Now I can either commit it locally or I can commit and push it to my remote repository. And so it pushes that, and I go back here to my browser. Now I can see here I've got my files, and it now includes both the lesson 5 Scratchpad and the lesson 6 Scratchpad, which shows our comparing people. So that's going to be all for today. Thank you. I'm going to clean up the code a bit tomorrow, and tomorrow we will get into using TestNG. And what we want to do, if you haven't looked at it by then, what we're going to do is we're going to implement some tests to make sure that when we compare our people, it will say, yes, these are the same people, and it will say Harry is an 11-year-old wizard, or Hermione is an 11-year-old witch, or Aaron is a very old muggle, things like that. Okay, thanks again. We will talk to you tomorrow. Do you have any questions, Arun?
No, I'm good. Yeah.